I'd like to thank everyone for attending. If you looked at the abstract on the website, you probably noticed that there was several speakers. We've had a few of them. One of them had to bow out due to political complications with his work. There was a tendency to believe that this presentation might have some information that was sensitive, that they simply violated, say, code of ethics just to talk about. But the message will be spread. We have with us today Sean Barnum, cybersecurity principal, and Chris Peterson from AppSec from Zynga. And so what we're going to be talking about today is the various ways in which you can abuse essentially the Facebook API through the gaming infrastructure, and how this can be used to do cyberbullying, play practical jokes, but also do some serious things. The final note I'd say about it is we discovered this research I did through prowling around, and I have some family that are completely addicted to Yoville, and they were getting attacked. So I just started digging into it, and one thing led to another, and it turned out to be, what I thought to be a topic worthy of talking about. A couple of disclaimers, though. One, we're not going to be hitting you with some brand new type of attack that's just going to blow your mind. Rather, this is more akin to if someone has skill with a man-in-the-middle proxy, they have malicious intent. This will show you a wide range of things they can do. So what we're talking about is that the damage that you can do with basic skills, and the malware and the structured attacks you'll see later on that will show actually originated out of the Philippines in February of this year. Okay? Oh, and finally, we're not here to bash Zynga or Facebook. We're just actually showing attacks that are actually happening. And in the remediation section, where we'll talk about solutions, you'll actually see some work that's been going on that's proactive to defend against the things that we're talking about. So first, I'd just like to show you on the very basic idea that down on the farm, I'm growing the good stuff. Believe me, I have a great farm, and I'm growing the OG Kush. So no one can touch my Farmville pad. This is actually where I grow it in my pad. But more important, the little shot you see, this is from Yoville. And Yoville has a meager population, you might say, of 8.8 million unique users per month. The total Zynga population of games that are out there at 254 million unique users per month. So we're not talking about a small user population. As you can see, that's enough people that it gives an incentive for phishing and all kinds of different attacks that might prey on people who aren't cybersecurity experts, who are in a position to trust what they see. And we're also going to talk about the reasons for why that trust exists in several slides. I'd really like to thank Chris for being here with us today. When we brought this matter to his attention, he was very gracious. We had several email discussions. He was already aware of it. There was already a solution in the works. The security fix has been developed by Facebook, and Sean's going to talk to you more about that toward the end. The Facebook application API can still be abused, and we'll also tell you why, and perhaps things that may happen in the future to make that more difficult. Why should you care, right? Do any of you out there play games on Facebook? Mafia Wars? Secret Delight? Don't want to admit it? Okay. Well, here are some statistics that show you the extent of the penetration of these games. There's currently over 80,000 apps on Facebook, any number of which could be potentially malicious. Social gaming, 1.6 billion this year, projected market cap of over 15 billion by 2015, so that's pretty significant. 300 million people in July is a lot. Now, one trend to realize is it's not just people playing on their PCs, but it may be people playing at work, or it may be people playing on their PDA, and all these things become new attack vectors for you. So what you're going to see is there's going to be instances where someone's mobile device is compromised because of a social game. And this can be a huge market for the underground. On a side note, I have a friend who was basically the going value of malware on the underground related to these things. He was offered $15,000 if he would write a piece of malware for these purposes. Of course, the most important point is social gaming is going on the networks you're trying to protect. So everything you're doing, however you're locking down your infrastructure, you've probably got someone out there gardening, at least planting seeds and waiting, and going to collect them later. And this is happening on your network. And so it actually inadvertently become a way of compromising the network and getting access to the inside. So I think these are a number of reasons why you really should care what's going on. Here's the roadmap we're going to take you. This was our brief introduction. We're going to talk about client-side trust attacks within application APIs, a number of attack patterns against social network gaming. And these attack patterns are really generalized. Sean will speak more to them. And they are general patterns of attack that go beyond Facebook or any Facebook applications, but can relate to any site where you have an application framework and an app within an app. Some of our impact sections, we'll use Yoville as an example. That's just one site that I was very familiar with and had family playing, and so I was sort of just focusing on that. And then lastly, most importantly, we're going to tell you how to keep your software off the stage. All right, Chris.
So, thank you, by the way, for allowing me to do this with you guys. I wanted to talk a little bit about some of the reasons for these issues that they've discovered in the network. And it's easy to sort of jump to the conclusion that it's just a bad architecture and that they've made some kind of fatal flaw in how they architected the system, and that's what led to these particular issues being there. But the reality is that it's a very complicated system that's been created, and there's multiple trust domains that are interacting with each other here. You've got the trust that the user has with the application framework itself, in this case Facebook. You've got the trust that the user has with the application itself, in this case Yoville. And then you've got the trust that goes on between the application and the framework, so between our Zynga applications and Facebook, for instance. And all of those various trust relationships are sort of distinct from each other, and the protocols and techniques that have been designed are specifically designed to protect the various trust boundaries. So in some of the techniques that you're going to see later in the presentation, there are attacks going on against the man-in-the-middle communication between the client and the application framework, and it seems like the obvious solution would be to just have the application itself send those messages directly to the back end of the framework and eliminate this whole scenario. The problem is that the application framework is actually responsible for protecting the privileged operations that the user is doing. And so these transactions need to originate from the user so that the framework can validate that in fact this is a user operation that they've authorized. So that leads to some of these issues. Now, as you'll see towards the end, they've actually done some stuff to improve this, but fundamentally the architecture is not flawed. It's just a very complicated relationship going on. Another thing that you'll see in some of these is that there's a lot of trust that's been placed in the client side of these operations between the application, say Zynga servers, and the Zynga client side application. And there's a reason for that as well. You know, as you saw earlier, our games are huge. We've got hundreds of millions of users playing every month, and in order for us to scale like that, we've got to push at least a large part of the processing of the game logic down to the client side. It's really the only way that we can scale with that size of user base. Some of the other things, though, that they've seen that are related to this, why this threat is so large, we've got the ubiquity of this across the network. So there's hundreds of millions, by the latest estimates, 500 million users using Facebook, 80,000 applications in Facebook itself. There's other social networks doing the same thing. These client-side apps are everywhere. They're becoming an interesting avenue for people to look at. Our users, unfortunately, also have a incentive. They've got a profit incentive to go into the games and respond to requests from other users and accept invitations, and that makes them somewhat vulnerable to attack. It's one of a big area of research that we do at Zynga, which is part of the social network interaction. And what we're seeing is that these represent an economy, a large economy. As you saw this year, virtual economy and social games is going to be on the order of $1.6 billion. projected to grow 10 times that much in the next 5 years. And so there's a lot of people out there that see this as an opportunity for them to get a piece of that pie illegitimately. And so we're seeing a lot of malicious activity. We're seeing a lot of people trying to build black market economies around the games. So that's one of the reasons why this is a big area of research that's going on. Okay, so I want to talk a little bit about how the actual application framework operates and what's going on. So the client app actually gets downloaded from the game servers when the user instantiates the game. It actually gets loaded, in most cases, into an iframe running inside the Facebook canvas. But that actual, in our case, Flash application talks directly to our back-end servers through our own API, and most of our interactions are through those servers. But occasionally, when we're invoking activities that involve the social network, such as sending invitations to other users or posting messages on someone's wall or something like that, then we have to go through the actual application framework that's provided by the social network. And so our back-end servers will initiate that operation through the client, and the client actually sends that message through that framework interface, and that's what initiates requests into the stream publishing, can access information about user profiles and friend lists and things like that. And so that's how these two APIs work. They're independent of each other, but they're also coupled.
So I'll start off by apologizing for sounding like a frog. This week has been harsh on my voice. Just wanted, before we dive into some of the attack patterns, wanted to call out explicitly some of the characteristics of this social network context and this application framework paradigm that kind of lends to it, making it more susceptible to attack. So first of all is this issue of trust. There's an inherent trust inside of these sort of contexts, where the attacks are coming from people that are within the circle of trust you've already defined, and by doing that, you're much more likely to fall for issues. You're much more likely to click on things, to understand things in a naive fashion than you would from things you would be suspect coming from the outside. The second is stealth. So all of these attacks are happening at the application logic layer. This is not your typical web attacks where you're looking at cross-site scripting and stuff and seeing scripts, seeing meta characters. The users are just seeing interactions with the application. They don't have any view below that. So it's a lot harder for them to actually detect whether something's malicious or whether it's not malicious. And lastly is this issue of urgency. So one of the bullets on one of the slides Chris just did was the psychological conditioning that a lot of these social networking, social gaming apps do. It kind of drives the user to trust the people who are within their network, and there's a temporal issue there. So sometimes when gifts go out and things go out, the user has to click on them a certain period of time, or they go away, or they're used up because there's a supply. So there's this conditioning to actually quickly trust and not put as much thought into it. So that sort of conditioning, once again, leads to being more susceptible to attack. And then this sort of context also brings with it certain attack perspectives. So one of those is it's very easy to do amplification attacks. Once you actually can compromise one user account, the very short hop, tight nature of the social networks means that you can leverage that account to quickly affect the people within their circle of trust, because then those people you can actually get to, and then from those people on. So just like other amplification attacks and networks, this one's even typically faster and easier because of that tight, short hop nature. Excuse me. Also deception. So this whole idea of trust that's in there is absolute fertile ground for anybody doing phishing, right? So it's very easy to actually create these messages, which you're going to see some of the techniques for doing these things, that look very real. They come from someone that you actually know and trust, and it's very easy to get somebody to click on a link or click on a button or do something that's going to actually take them somewhere else. In the case of some of the buttons, which Tom will talk about, just like some of the Java action-type buttons you see in other things, the user, the naive user, many times using these applications, can't just do a mouse over and actually see where it's going to. So it's very easy to do phishing attacks with this kind of stuff. And then lastly, it's very simple to exploit. So Tom said that this is not really deep technical foo. Anybody with a Peros proxy and basic knowledge of how web applications communicate back and forth, it's very easy in most of these frameworks now that communicate back and forth to actually create false, completely spoofed content, or to actually modify content on the fly and do all of these things. It's just inherent in the paradigm that's actually here. We'll talk a little bit about some of the mitigations at the end that are making this a little more difficult. But if you're either building and operating an application framework for something like this, or you're building applications to work with it, it really does take careful, proactive thought to think through these issues and address them at a strategic rather than just a tactical level to actually tackle this stuff. So the framework we're going to use for talking about this stuff today is really focused around attack patterns. So attack patterns are generalizations off of certain instances of attacks. So we're not going to be talking with here's the exact exploit code for doing something. We're taking a step back and saying there's certain patterns that apply to these sorts of architectures, these sorts of contexts. And anybody with a basic knowledge on how to do a software attack can look at these patterns and instantiate that in